Hi everyone, my name is Brittany Taylor. I am a medical laboratory technician for Wake Forest Baptist Hospital in the Clinical Pathology Microbiology Laboratory, and today I'm going to be talking to you about my proposal, which is for an evaluation of wound culture bacterial growth and isolation by utilizing an automated specimen processor known as the BD Kiestra InoqulA for standardizing culture inoculation methods within our laboratory. Like other laboratory departments, the Clinical Microbiology Laboratory relies on standardization to provide accurate results within a timely manner. Unfortunately, outdated manual inoculation methods risk unintentional processing variations, such as the amount of specimen inoculated and the technique utilized by the individual technician. Heavily inoculated cultures can cause delays in organism identification as well as antibiotic susceptibility testing, thus impeding effective patient care and may even prolong hospital admittance. Polymicrobial bacterial infections also play a major role in contributing to delayed results. These can be caused by multi-drug resistant bacteria, also known as MDROs, also from biofilm formations. You see a lot of these types of infections with people who suffer from diabetes, have diabetic ulcers of the foot, toe, and leg, and also from obesity. As you can see on the slide, there are two agar plates here. The polymicrobial wound culture B, located there at the bottom, actually has 5 to 6 different bacterial organisms, I believe, that was growing in that culture. The aim of this study was to analyze the number of isolated bacterial colonies from wound cultures that had been prepared by the current manual inoculation method versus standardized processing by the BD Kiestra InoqulA. Implementing new technologies into the microbiology laboratory can standardize inoculation to expedite and improve bacterial culture results. The proper culture medium is inoculated every time, and this also includes broth medium. The precise amount of specimen is inoculated every time, and this is also customizable. For the proposal research I did, I used 10 microliters. And there's also a standardized isolation and streaking method that was patented by BD. It's called the rolling bead technology, and it is a magnetic bead which rolls across the surface of the agar, and it pulls the specimen in an even distribution around the plate. There have been several publications so far in regards to implementing automation in the microbiology laboratory. Some of those included here are from Moreno Camacho in 2017, who had reported decreased ID and antimicrobial sensitivity results from greater than or equal to 3 days to approximately 2 days. Yu and his colleagues in 2020, and this is a facility in China, they had concluded a 45% reduction in inoculation processing time per hour using automation. The accuracy is also standardized. Automated processing increased colony counts from 41 isolated colonies plus or minus 35 to 92 plus or minus 117, and this was with a p-value of 0.011. And if anyone remembers from statistics, the lower p-value you have, the more of a chance that your results aren't from chance, that they are actual legitimate results. And that was also reported from Yu and his colleagues in 2020. Precision is also standardized when you implement laboratory automation. Research proposal by Mutters had described how he had earlier inconsistent organism identification that actually resulted in a treatment regimen change for 12% of the patients at their facility. Okay, so now for the fun part. You're probably thinking, where is she going with all this jibber jabber? When are we going to get to the good stuff? How did I actually make all of this come together? Well, you would think that would be easy. So what I did was I had 20 patient wound culture samples that were processed by the manual method, and these were done by a tech. I did not know who the tech was that had set everything up. I wanted to keep all of that completely in the blind for me. And I had taken those same 20 patient wound cultures and I had processed them on the InoqulA. Then I evaluated all of the cultures, the manual method cultures and the automated method cultures, and I performed semi-quantitation on them, which is the 1 plus 2 plus 3 plus 4 plus quantitation we use in microbiology. And I also counted the number of actual isolated colonies on each agar plate. And what was considered an isolated colony was a colony that had no other colony, even of the same species, touching any of the surrounding borders or edges of that bacterial isolate. So this slide here shows a bit more of an outline format of the whole process that I went through with setting up my culture plates. So we have the first step that I did was sample preparation and processing. The manual method, as mentioned before, that was set up by the tech who was working the hood that night. They were the ones that were doing the direct inoculation, and all of them, the cultures, they were set up to sheep blood agar plates, SBAPs. Now, for the automated method that I performed, I had first taken the wound cultures and I had created a 0.5 to 1.0 McFarland standard for each of them. And that was to just ensure that the turbidity, the concentration for all of my samples were going to be approximately the same for each of the 20 cultures that I did. Afterwards, I had set up the sheep blood agar plates on the InoqulA, and I had used a 10 microliter pipette and I had dispensed that onto the sheep blood agar plate. And this was with the InoqulA in what's called a semi-automation mode. Afterwards, the sterile magnetic bead that does the streaking for isolation on the agar, I had used a sterile pair of forceps, and I had placed one of the beads onto each of the augers for isolation, and then I had used the streaking pattern 18, which is a 4-quadrant streak pattern, much like you remember in microbiology when we use the inoculating loop. The InoqulA also has that same pattern, and so that was the one that I had selected to be performed for each of the cultures. After they were set up, all of the plates, they were incubated at 35 plus or minus 2 degrees in ambient atmosphere, and this was for approximately 12 to 17 hours because I wanted to keep the incubation time of the original sheep blood agar, which was my blind plate, the one I did not know which tech had set it up. I wanted to keep the incubation times approximately the same, and since I work third shift, a lot of that, I had to do a little bit of math in figuring that out. So the times that each culture had been incubated was approximately 12 hours to 17 hours. Once I had pulled out my plates, I semi-quantitation, I did my evaluation on it with that, the 1 plus 2 plus 3 plus 4 plus. I also performed a multi-TOF MS mass spec identification for all the isolates. And then those isolated colonies that I identified, I had individually counted each one. And again, those were completely free of contact from any other microorganism colony. So this table right here, this is the evaluation of manual processing method versus automated processing method, the InoqulA, for isolated colonies by sample and species. So you will notice that I have all 20 of the samples here by sample number, and I've also included the source. Sometimes that's really interesting, and you can see how quite a few of them are like number 1, number 2, left foot chronic ulcer, diabetic ulcer, number 6, right leg chronic ulcer, number 8, right toe abscess. We have a lot of diabetic injuries, and a lot of these that come in, they are polymicrobial samples. Under each of the columns for manual method and automated method, I have my semi-quantitation for each one, and right next to that I have the number of isolated colonies that I had counted by sample and also by the isolated organism by species. And you can see that comparing the manual method to the automated method, there was a very large increase. Just in sample number 1 alone, from the amount of isolated colonies I had from E. coli, going from 3 on the manual method to 27 on the automated method. And I do have some pictures to display some of these. And here at the bottom, you will see I have the total number of isolated colonies by method. Now, I did have 2 outliers in here, and I will show those in just a moment on another table. But I also have the mean number of isolated colonies per sample by method, including and having outliers removed. And you can see how the mean difference has just increased drastically with going to the automated method. It was a difference with including outliers of a 133% increase, and with outliers removed, it was 132.19% increase. Here is an image of sample number 5, unspecified wound location. The left-hand side is the manual processing method, and you can see there was an identification of Staphylococcus lugdunensis, 18 colonies, and a Streptococcus canis, 7 colonies, completely isolated, totaling 35. This next sample is number 3, a hepatic abscess, again showing the difference from a clustered first quadrant culture plate to a culture plate that has many isolated and completely separated colonies. And this would actually be quantitated the same, even though the first plate looks like it has a lot more bacteria on it. I would quantitate the second plate here as a 2 to 3 plus, given the growth, how far out the colonies are growing from that original inoculation point. Now that I had collected my data, I needed to perform standard deviation to prove that my data had a normal distribution, so that way I could go on to the next step, which is to find out if I had any outlying data. As you can see from this next table, I did have 2 outliers, but my standard deviation was actually, it was normally distributed, it was slightly skewed, and now these results here are after I had removed the outliers. Once you perform a standard deviation and you have normal distribution, then you need to determine if your data set has any outliers, and that's done with the Grubbs' test. My null hypothesis was that my data set does not contain outliers, but as you can see, I actually did have 2 of them. I had my sample 2, my automated, and my manual were suspect, so I performed the Grubbs' test. The automated was actually not an outlier, while the sample number 2, the manual count, was an outlier. So I just completely removed the sample altogether. And my sample number 9, with an outstanding 133 isolated colonies I counted, was most definitely an outlier from my automated method, so that sample was removed as well.